Exercise 10.3. First one, find the differential equation. You have to find the differential equation of the family of all non-vertical lines in a plane. So first we should know what is a vertical line. So vertical line, you know what are the vertical lines? The lines which are parallel to the y-axis. So the question is actually non-vertical lines. So first you should know what are the vertical lines. If the lines are vertical, so this is the slope. The slope is m. The slope m is tan 90. M is tan 90. So m is infinity. Tan 90 is infinity. 90 is the angle made by the line with the x-axis. If the lines are vertical lines, the angle will be always 90. So m is infinity. So the non-vertical lines means m will not be equal to infinity. The slope is not equal to infinity. So first thing is the non-vertical lines. The equation of the non-vertical lines will be y is mx plus c, but m, the slope is not equal to infinity. So now these two m and c are called as arbitrary constants. M and c are the arbitrary constant. There are two types of constants. One is fixed constant, the other one is arbitrary constant. So the arbitrary constant is, suppose if the equation is y is, when I say y is 4x plus c, this 4 is called as the fixed constant. It's not going to change for that particular line, but c you can change. So the c is an arbitrary constant. When you change c as 1, you get one line. If you write c as 2, you get another line. So as you change c, you get infinite number of lines. So c is, even though c is a constant, as it changes, you get different lines. So the c is called as an arbitrary constant. 4 is fixed here. So it is called as a fixed constant. Suppose the equation is y is equal to mx plus 10. So in this case, m is called as the arbitrary constant and 10 is called as the fixed constant. So here in this you have both you have m, c. So m and c are, both are arbitrary constants. Nothing is fixed here. Nothing is given about that. You are writing a general equation. So both are arbitrary constants. So that means there are two arbitrary constants. There are two arbitrary constants. That means to form the differential equation, you have to differentiate twice. See, when the question is form the differential equation, that means you have to remove this m and c. The differential equation should not have m and c. Both are arbitrary constants. So whenever you have to form a differential equation, there should not be any arbitrary constants. You can have fixed constants. So there should not be any arbitrary constants. Now the rule is, if there is only one arbitrary constant, you have to differentiate only once. If there are two, then you have to differentiate twice. Only then you can eliminate these arbitrary constants. So the question is y is mx plus c. So dy by dx is, first when you differentiate mx you get m. This is a constant, it will become 0. Now m you have to differentiate again because m should be eliminated. So differentiate again. So d square, the second order derivative, that is differentiate this again. So d square y by dx square is equal to 0. So this is the differential equation of non-vertical lines. Now the second part of the question is non-horizontal lines. Non-horizontal lines. So first you know horizontal lines. Which are the horizontal lines? So this is a horizontal line. So whenever a line is horizontal, what will happen to the slope? M will be 0 because the angle made by this line with the x-axis is 0. M is tan theta. Theta is the angle made by the line with the x-axis. So tan theta, the angle is 0. So it is tan 0 is equal to 0. So m is tan 0, that is equal to 0. So the equation is y is mx plus c. So non-horizontal lines, m will be not equal to 0. All the other lines are called non-horizontal lines. When m is equal to 0, it will become a horizontal line. When m is not equal to this, when the slope is not equal to 0, it will become a non-horizontal line. So y is mx plus c, m is not equal to 0. So when you derivate this, again m and c are arbitrary constants. M and c are arbitrary constants. So that means there are two arbitrary constants. You have to derivate twice. So let us see now. Dy by dx is equal to m, right? Now m is not equal to 0. That means m can be infinity also, right? M is not equal to 0. There is an option that m can be infinity. So when m is not defined, you cannot differentiate this, because you have to differentiate again, because to eliminate these two arbitrary constants you have to differentiate again. So dy by dx is m. When m is infinity, you cannot differentiate this again. So to avoid that, you take the reciprocal here. So dx by dy is 1 by m. So now this will never become infinity, isn't it? Because if m is infinity, 1 by m will become 0. If m is 5, 1 by 5 is this is a constant. M is a constant, 1 by m is also a constant. If m is 10, 1 by m is 1 by 10. This is a constant anyway, it is not going to change. If m is infinity, approaching infinity, 1 by m will approach 0. So this is the constant now. Now differentiate. So the second derivative of this is d square x by dy square. This is a constant anyway. When you differentiate this, this will become 0. So the differential equation of non-horizontal lines will be d square x by dy square, or sometimes you can also write, this is also okay only, dy by dx is m is some constant, but m is, so you can also just write d square y by dx square is 0. When m is, assuming m is not reaching infinity, in that case you can write this also. Both are okay, but m can also be a huge number, m can be infinity. In that case 1 by m you have to write, okay.